Hello, my name is Oscar, and today I'll be testing my Node Labs program and determining whether things are a pass, partial, or fail in the success criteria of my post-development testing for my computer science project. 0.1. When the program is loaded, the user is taken to the landing page to either log in or register. This is the first screen on over here that you can see that you would be taken to when the program is opened. So yes, that is a pass. When the user is logged in, they are taken to the main menu page. I haven't created any logins yet, so I will be registering one. So I'm going to just create a mock login here. Testing user. I will come back to the login and registration system testing later, but we are first looking at number naught, which is have a consistent event-driven graphical user interface, which is easy, which users find easy to navigate and an engaging experience. So this is the current part of the program we are testing. We'll come back to the login and registration system. We're just going to log in now. Well, register now to show that when the user is logged in, they are taken to the main menu page. So as you can see here, this is the main menu page. So that is also a pass. 0.3. When the user presses a button labeled graph generation, the graph generator will be loaded as the interface. This will be the same for the buttons leading to other parts of the program. So we can see here, this when we press graph generation, we are led to the graph generation scene. Sandbox scene, quiz mode, quiz scene, leaderboard scene. User stats I did not complete in the development, so it does not lead to anything. So I'd say that this is a pass because yeah, all of these buttons work and lead to their respective parts of the program, apart from the user stats. Zero point 0.4. If the user is not in the main menu and logged in, they can press the back button to return to the main menu. So here we can see if we open the graph generation, there is a back button, it's called return, that takes us back to the main menu. If we've finished using the sandbox mode or finished using the quiz mode, we can return to this main menu here and use another mode. And that is true for each of these. Okay, now that I'm finished with the success criteria for number 0, we will now go on to number 1, which is the registration and login system. So, when users are registering, they must put in a proper email address with the @ symbol. So to test this, we'll make some mock usernames. Let's go testing 2. Gmail. Here we'll put in something random for the email, so random without the @ symbol, random@gmail.com. And password, we'll use a strong password so that we can see that the only thing here that this is lacking is the @ symbol, which shows that we cannot submit it without an @ symbol. So that test has passed. What's also part of this is the .com. So if we have the @ symbol but without the .com, and we try to submit it, we'll get the error message saying the email is invalid. So we need to put that back in. When the user is creating now, so we can see that 1.1 has passed. We're going to move on to 1.2. When the user is creating a password, they must put in a strong password of length 6 containing a number, symbol, uppercase and lowercase letter. So for this, I have used secret case, so you cannot see what I'm typing, unfortunately, but what I'm going to type here is a password of 5, length 5, and that will show that an error. This error is pulled up, so the password must contain it, and it tells us how we should create a strong password. And of course, so once we exit that and try another password, say without numbers, without numbers this time, yeah, this error comes up until it comes up every time until we enter numbers, lowercase, uppercase, symbols, which then will allow me to go in to the program, as you can see here. So we just used, so let's log out now and test 1.3. When users press the register button, their credentials are stored in the user data table. That is true because I can try, let's see, let's make another fake username and password, oscar@fast.com, username of Oscar5, or just Oscar Fast for simplicity so I can remember this, and the password, 1, 2, 3, exclamation mark. So we look at these details and we submit this, we log back out, we can use these same details again. So what did I use? Oscar@fast.com, Oscar 1, 2, 3, and we can see, oops, that we've logged in back to the main menu with these details to prove that the data that we registered with has been stored in the login, stored as a login that we can use later on. One 1.4. When the user enters invalid data upon registration, an appropriate error message is displayed. Well, we've already showcased that, but we can showcase it again. We'll go Oscar at ASDF. We'll see that we got invalid password because we haven't got anything in there, but if we had a valid password, we can see that the email is invalid, and that shows that that is a success. 1.5, user passwords are stored as hash digests. I can't show this here, but I'll provide a screenshot in the post-development testing later of this working. 1.6, when users enter credentials that are in the user database, they are successfully logged in. Well, we already showed that again, so we showed that here with this username and this password. We're logged in. So we can also use the username, which I cannot remember, so I will just register make another registration. So we'll make the username easy to remember, so coffee, and the password will be and then we'll log out and we'll try coffee again. And we can see that those credentials work for either the username or password when logging in. And you can see if we enter incorrect details, so details that don't exist in the database, so we'll go with Jackson and password. We can see that we are not allowed access to the database, or not allowed access to the main menu because these credentials are wrong. When a user's credentials cannot be found in so that 1.7 is a partial because I did not put an error message. So now we're going to move on to graph generation. I'm just going to quickly create some random testing, random registration details to log myself in. Testing account, password. And now we're going to go to the graph generation section and test the success criteria here. So, to be able to generate a graph on the press of the submit button with the number of nodes the user has specified and a random number of edges for each node, and that weights, heuristics, node identifiers, and directions are understandable to the end user. So I'm going to do all of this testing here. We can see we can generate this graphs of number of nodes 5. We can count 1, 2, 3, 4, 5. This works where we can increase that number to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that when we change the number of nodes, and press generate, these nodes are now generated. And so 2.1 is kind of in combination with 2.2, which has changed properties of the graph like weight, direction, heuristics with toggleable buttons. Unfortunately, due to time constraints, I was not able to complete the A-star algorithm and consequently add heuristics. So this is a obviously going to be a partial one, but we can see that we can generate a weighted graph here. We can generate a directed graph here. We can generate both a weighted and directed graph here. And we've got a random number of edges each time. We can increase and decrease this edge probability factor here, which will mean that edges are either less likely to appear or more likely to appear. We can create a complete graph where all the edges are, each edge is connected to each other, each node is connected to every other node at edge probability 1. We can see that here, and if we can adjust this down to 0, where we've got a graph of no edges. So the randomness of that is a success. So everything here is a success apart from the heuristics. So 2.3. To be able to input a root and end node and click a button that outputs the shortest path between two nodes, either using Dijkstra's or A-star algorithm. This output will highlight each node that the algorithm processes. The graph must also be checked that it is one of the correct formats before running, e.g. one cannot run Dijkstra's on an unweighted graph. Okay, so let's generate a weighted graph to fast show that you can run Dijkstra's here. They can, as you can see here, the default placeholder text is 0 and 6. So if I don't change the source node and run Dijkstra's algorithm, we will see that 0 to 6 is the only path that is highlighted here. So, but I can change the source node and start node however I wish to. So we could say, well, let's use two that are far away from each other. So we'll do 3 and 4 and run Dijkstra's again. We can see that the shortest path is this one here, 3 to 4. This might be a bit confusing because 2 and 4 are connected to each other, not so unfortunately that is a slight issue with legibility. You might get confused that 0 and 4 are connected, but here they are not connected. We can choose another example. You can switch them. Let's go with 0 or 5 and 0. And we can run Dijkstra like that, and you can see that you can choose source or goal nodes. as you wish. However, you cannot input source nodes that are invalid. So say 9, there is no source node of 9, so we're going to get an error message which gives us the invalid source node. And if we try and input something else like frog in goal node, that's going to delete the text and say it's an invalid goal node. Since these are both invalid, they will reset to 0 and node count -1, which is the last node created, and 6. So that's what they reset to. So you can still run Dijkstra's. Here when they reset to 0 and 6, as shown. We can also generate another graph, which is unweighted, and try and run Dijkstra's here, but we get an error message. We cannot run Dijkstra's on an unweighted graph. This means that the graph must be the correct format, so even if we put directions on it and try to run it again, oh no, we can't run Dijkstra's on an unweighted graph. We can also see 2.4, which is to be able to show a graph in an adjacency matrix or an adjacency list format on the click of the button. So let's generate a new graph. Pop that down a little bit so we can generate a nice clear graph, so that I can show you a nice clear graph that you can understand. Here we are. So upon the click of this adjacency matrix button, we can see that the adjacency matrix for this is correctly outputted. So this is the first row is node 0. Node 0 is that node, and we can see it's connected to no other nodes. So it's going to have -1 as all its connections, and 0, the distance of 0 to itself, of course. Okay, so I won't go through all of the adjacency matrix rows, but as you can see, so this row number 0, 1, 2, 3 is connected to node 0, 1, 2, so connected to node 2 and node 0, 1, 2, 3, node 4 of weights 10 and 47, and that is node. So we can check that here. We can see that node 3 is connected 47 and 10. 10 and 47, node 3, adjacency matrix, 10 and 47. We can also check this from the adjacency list, as shown here. Of course, node 0 has no connections, and these show the connections between other nodes with the corresponding weight. So node 1 is only connected to node 4 with a weight of 28. Node 1 only connected to node 4 with a weight of 28, and of course node 0 connected to nothing. So we're now going to look at 2.5, which is to be able to delete an existing graph using a clear button and generate a new graph. Well, I actually kind of implemented this feature within the generate feature. As you can see here, we clear the graph, and the previous graph is cleared, and a new graph is generated every time. So that is a pass. So yeah, that is the graph generation module. Now let's move on to the graph creation module, which is also known as my sandbox module. I kind of called them two different things, don't really know why, but creation, sandbox, either is to call it either is fine. So 3.1, for the user to be able to place graph nodes in a valid area for creating graphs after pressing a button to add nodes. So here, pressing the add node button, we can see that you can create a graph like such. But if we try and create a graph node too close to another one, we get an error message saying cannot place graph nodes too close to each other. So try again, we can't. So we'll place another one here. So that is a success. After pressing a button to add edges, the user is able to select two different nodes and create an edge between them. We can do that. This is 3.2, and we can do that by pressing add edges. You can see here 0 to 1, an edge is created like that. 0 to 5, edge is created here. Each time we press 1, we select a node. Each time we select a node, it changes color to orange briefly to show that we selected it, and we can actually unselect it by clicking it again. So if we want to, we've decided we want to get another node here, another edge between 1 and 5, we can create that like such. The user should also be able to change properties of nodes and edges of the graph, such as weights, directions, and heuristics with toggleable buttons, and adjust them in a trace table. Well, this is going to be a partial, because whilst I did allow for things to be adjustable, such as weight and direction, so we can see here I'm adding a weighted and directed, forgot to press the add edges button. I can add a weighted and directed edge between these two, 1 and 5. And we can change this weight with the click of a button here. So that was in place of the trace table of nodes, that because I found this would be a much easier solution to develop. So we can change that to 5, say, and we can tell that that's actually been changed. If we look in the adjacency matrix, and we can see that for nodes 1 to 5, or adjacency list, we've got node 1 is connected to node 5 with a weight of 5. But of course, it's a directed edge, so there's no connection between 5 and 1, as you can see here. So that also shows that the adjacency matrix and list properly update along with this creating nodes. But yeah, we can also create just directed ones, just weighted ones, just directed ones, and as you can see, when we pick our start node as the first one, and the end node as the second one, will create the arrowhead from 5 to 3 for the first one, from the first one to the second one. You also can't create nodes on top of each other. You can't create two edges of the same sort, of going from this 5 to 3. Yeah, because we can't do that. So that they don't double, so weights don't double up. So as you can see, if we try and create another weighted one here, another edge will not be created, as another weight might overlap with the current weight here and making it illegible. 3.4a. The user should be able to run Dijkstra's algorithm on a created graph. So let's clear this current graph because it's got unweighted edges, and let's create a graph, a simple graph to run Dijkstra's on. And we'll add weighted edges. So we're going to do perhaps this path from 0 to 5, and we can add other options, quicker options to go to, and we can say edit these weights here too. So that could be 5, that could be 1, that can be 8, that can be 4, that can be 20. And we can run Dijkstra's algorithm from 0 to, say, 5. When we run this algorithm, we can see here that the path, the shortest path is found, and yeah, that is shows that the Dijkstra's algorithm works. We can also see that this works with directed graphs as well, weighted and directed graphs. So I'll highlight that with create another graph. So we'll try 0 to 6 this time, and we can see that these edges here should not be used as part of the shortest path. So because they're not correctly directed towards they're one-way edges, so we cannot traverse across them, but we can only traverse across this part here if we run Dijkstra's. If we run Dijkstra's like such, with source nodes 0 to 6, you can see that these edges are taken over these edges, since we cannot actually reach these edges due to their kind of one-directional nature. (3.4b) The user may be able to run the A-star algorithm on a created graph. Well, we weren't able to create the A-star algorithm, thus we cannot run the A-star algorithm on this graph, making that a fail. This module will also need a clear button, like the graph generation module, in order for the user to make a new graph. This is 3.5, and we can see, well, I've already showcased it, but when we make a little graph, we can press the clear button, and that completely clears the graph. So that is it for the graph creation module. And now I'm going to go into the objective number 4, which is the pathfinding algorithms module. So both graph creation and graph generation mode should have a trace table that updates when a pathfinding algorithm is being run. They should also be able to show adjacency matrix and adjacency list format. Well, we sort of already showed some of this, but I'll show it again just for the sake of putting accurate timestamps in for every success criteria. 4.1. In both graph generation and creation, a trace table should update with the running of a pathfinding algorithm. So, as I said, I've already kind of showcased this, but let's just make a quick graph here. And we enter source nodes 1, 2, 3. You run that. We see that a distance table appears, which is basically acting as our trace table here. So yeah, that is a success here, and we can show that in the graph generation area 2. I'll generate a weighted graph, and we'll run that algorithm with which should generate from 0 to 4, 0 to 4, 40. And we can see that the distance table updates here as well, showing that's a success. 4.2. There should be a mode where one can see the adjacency matrix format of the graph instead of the logical representation. Again, I've sort of showcased this already, and adjacency list is 4.3. Showcase this, just showcasing these once again. Okay, that is the end of of testing part 4, and now I'm going to go into part 5, which is the quiz mode. The quiz mode objective, which is a quiz mode should generate graphs and ask users for the shortest path from 2 nodes and the total distance. So the quiz mode begins with pressing the start button. You can, and it will generate both weighted and undirected graphs and weighted and directed graphs, and will ask us for the shortest path between nodes, between the kind of first and last node made. That's a pretty difficult graph to navigate, so I'll try and start with more simple graph that I can explain. There we go. Actually, perhaps not that one. I'll keep trying until I find a good graph. Okay, here we are. So 5.1. The mode should generate graphs and a question asking what the shortest path between two nodes is. So as we can see, graphs are generated, questions over here, find the shortest path and distance between nodes 0 and 5. This does not look like it's got a oh, it does. So that would be 0, 4, 1 and 5. 0, 4, 1, 5. And the distance would be 33 plus 13, which is 46. No, 33 plus 32, which is 65, plus 24, which would be 89. And we'll submit that as an answer, and we see that that's the correct answer, which leads us on to 5.2. If the user guesses the correct route and distance, their score should be incremented appropriately. I will show this at the end, as the score is shown at the end. Well, I'll show this after 5.3, that the show is done correctly. So we'll move on to the next question, since we got this question right, and say we get that correct answer as well, because there was no path there. No path. There is a path here. There is a path 0, 4, 2, 5, but we're going to ignore it. I'm going to press no, and we're going to enter in some random nonsense. So that is not, of course, the path, and we'll enter like a random distance too. So 2,000, which we obviously not. So we got, and when we submit this answer, we can see that our score is put over there, and we got it incorrect. So it displays to the user that they've guessed incorrectly. They should see the algorithm run. We can see the algorithm running over here from 0, 2, and 5, which was actually, I got that wrong, but yeah, it's 0, 2, and 5, and we can see the path total distance here, 42, and along with the distance table. So if you're a user using this part of the module, you can see where you went wrong, basically. And it also shows you your username and score, which added to the leaderboard. And also an exit button, which will take you back to the main menu. We can also see that there are checks for this. So if we try and start this, we can try, if we try and enter a distance that is invalid, say invalid, and the shortest path here, well, doesn't really matter because we're kind of trying to show that the distance is invalid, so it doesn't matter. We can see that an invalid distance has been inputted. The distance has changed from to a blank distance, and we can safely close this. So yeah, we can't type anything in the distance that is not in integer. So there is validation checks there. That moves us on to testing our leaderboard. 6.1. A refresh button will allow users to see if any changes have been made to the leaderboard. So while I have not implemented a refresh button, I automatically refresh the leaderboard after a user has finished their game. So we can see here, Oscar Wilshire is position 5, testing account is position 4 with a score of 3. So if I go into the graph quiz mode and I start a graph question, and we'll find the shortest path between, so that looks like it's 0, 3, 7, and we can see that distance looks like it is 24 and 22, so that looks like 46. Submit the answer. Oh, we got that incorrect. Oh, there was another way. I didn't see that, but testing account has got a score of 0. We can see that in the leaderboard that doesn't change anything for testing account here, but it does add another testing account at the bottom with a new score showing that the leaderboard refreshes upon finishing a game. So we can just try that again. The quiz mode will start. Just find a decent set of graphs. So we can see here that's 19 and 27. 2, 5 to 27, 2, 7, sorry. And the distance is 27 plus 19, which will be 46. Submit the answer. And oh no, it's another incorrect game. That's one of the unfortunate things about my graph generation is that the graphs are often quite difficult to read, which also does account for part of the success criteria being partial in the graph generation, not a pass. So let's see, 0 to 5 looks like it's going to be 18 to 30, 18 plus 34, so that's 0 to 5, and the distance is 34 plus 18, which would be 48, 52. Can submit that answer, get it correct. 0 to 6, that looks like it's going to be 4 plus 51, and 0 to 6, submit our answer. Oh no, there was a shorter route of 37 that I missed. And we get a score of 3 with testing account again. We go to the leaderboard, we can see that there is another testing account with a score of 3. So that shows that the leaderboard works, and that 6.3, that if the user has gotten a score after playing quiz mode, it's added to the leaderboard, it's a pass. There should be a descending order. There should be a table in descending order for the leaderboard. That's also a pass, as we can see here. There are some mock results that I put in with scores that are obviously a lot higher than anyone could possibly get, but as you can see here, the highest scores come first. It's position 1, 2, 3, etc. So, yeah, the users will be able to see scores on the leaderboard in the correct position. That is partially part of 6.2, and that's also a pass, as we can see here. And lastly, everything in 7 is a fail because, of course, we have not. I've not developed user stats and this user statistics page, so a right and wrong answers page for users to see their right and wrong Dijkstra's A-star algorithms that they've solved is unavailable because it was not developed. So the whole of number 7 is a fail. And with that, my testing has concluded, and you can see in the post-development testing table all of the timestamps to the different parts of the video where I've either passed, partially passed, or failed tests. Thank you.